Hello students, welcome to Power Tutorials. So today we are going to cover part 3 of Light chapter, which is chapter 9 of Science Class and CBSE, that is NCERT textbook. The chapter is Light, Refraction and Refraction, and today we are going to cover convex mirror, like how the object image is getting created by the convex mirror, and also we are going to cover sign convention and the mirror formula. Okay, so this is, as I'm saying, part 3 because it's not part 3, this is part 2. Okay, in part 0 I have explained what is an mirror, how the object can be seen by the nature, why we cannot see objects in the dark like cave, that we have covered. I also covered what is spherical mirrors, and in detail I have explained what is hollow sphere and how from where we can create convex as well as concave mirrors. Those we have covered, and then the parts reflection basics has been covered in part 0. Then I have explained in part 1, I explained about loss of reflection, and I explained what is convex and concave in detail, and also we have started with terms of the convex mirrors like pole, what is focus, what is radius, what is focal length. Those we have covered. And then 4 important points with respect to spherical mirrors for ray diagram we have covered. And then we also started with concave mirror, what are the images will get created when the object is placed at infinity, beyond C, at C, between C and F, at F, and also between F and P. All those we have covered for concave mirror. Okay, now we are going to start part 2. So here we are going to cover the images which is getting created by convex mirrors, and then before going to that we need to cover the uses of concave mirror. Okay, so where are the concave mirrors getting used? You can see from the diagrams, you can understand. The first one is torchlight. So I am sure that everyone must have used torchlight in their life. So what is torchlight means? It is a kind of device which will have a batteries inside it, and nowadays we also have like charger connected devices, so using which you're able to see a light which is covering major area. How it is covering major area? Why? Because here at this part you will be having a concave mirrors. Okay, so due to this concave mirror the light will get transmitted faster. And second, headlights of automobiles. Automobiles in sense like bikes, cars, tractors or anything. Okay, so if you notice the headlamp, around the bulb you can see some silvery kind of structure, something like in detail it will be inside, there will be a bulb, and surrounding it you can see there will be a shiny surface, and then the light will be projected more distance. So how the light is projecting more distance means this light is falling on this concave mirror and then it is getting reflected. Okay, that's why it is getting transmitted to a larger distance, and then this light mostly will be placed at the focus of the concave mirror so that it will be having light to the infinity, the reflection to the infinity. Okay, these are the main 2 examples, and the third example I am also saying as a solar heater. Solar heater or solar cooker also it can say. So what happens in solar heater or cooker means the whichever object has to get gets heated up has to be placed at the focus of the mirror. Like suppose for solar cooker I can say something like this will be the concave mirror, and the focus of this concave mirror will be somewhere here. So here we will place the cooker. So what happens? So what are the sunlights which are getting from infinity? What they will happen? It will get reflected towards the focus. So all the lights are getting reflected to a single point, and here the major heat will be observed, due to which the cooker or the electric appliances which we want to get heated up will be placed, and that will get burnt. Okay, so this is example for solar cooker. So how the solar cooker is happening? At the focus of the concave mirror will place the cooker, and all the radiations from the sun will get reflected from the concave mirror, and that will be reflected towards the focus. Okay, so this is the uses of concave mirrors. You have to say torchlight, headlights of automobiles, and also solar cooker. Okay, now we are going to cover the images found by convex mirrors if it is placed at 2 places only, because we always place the object at the left side. What about convex mirrors? We have the center focus at here and center at somewhere here, and we have the pole at here. So but we have to place only object at this side, not to this side. If we place this side, there will be no image created because this is the rough side. This is the shiny surface. So to get an image of any convex mirror, you have to place object at here, but the focus, center, everything are on the right side. So we can have only two things. One, first case when object is at infinity, means somewhere here. When object is in infinity, we have to follow the same rules. First, if it is parallel to the convex mirror, I'll use different color. Let's use pink. If it is parallel to the convex mirror, what I had told you, if it is parallel to the principal axis, the line should get reflected from the focus, but the focus is this side. So what will happen is just imaginary line dotted, this will get reflected in this way, imaginary line again dotted, this will get in this way, imaginary line dotted this way, and this will get reflected. So here these lines we cannot get intersected at any point, so we have to just draw it backward, and somewhere at the exactly at the focus all they will get converged. So with respect to image, so what is you need? First one, size, point sized, position, where it is placed at focus, and second, it is behind the mirror. What is the nature? Nature of the image is virtual and erect. Okay, let's say about second place. Second means somewhere nearer to the mirror. So let's skip somewhere here. So this is the object AP. This is a mirror. So here we'll have focus and here we'll have center. So first I will draw which is parallel to principal axis. If I draw a line which is parallel to principal axis, it will get reflected to the focus. Second, if I draw a line passing through the center, if I draw a line passing through the center, what is the condition? It will get reflected at the same path. So if these two rays, if I get backward, I am getting the intersection point at here. So this is the image. Okay, now let's think about the image properties. First point, position. Let's use another color. Position of the image, it is between P and F, and it is behind the mirror. What about size? Small. Nature, virtual and erect. Okay, let me write little lead this point. Position is between P and F and behind the mirror. Okay, so in this way both the positions are done, because anyway if you keep here or here, the position, the image will be created exactly at between P and F. Now, what are the uses of convex mirror? So convex mirror main uses, if you keep any object nearer to the convex mirror, what is happening? The size is getting decreased. Okay, instead of larger it will get decreased, but will not, there is no chance that the size will get increased. So the main advantage is wherever we require the larger to capture larger image to a larger object to a smallest size, in such cases we have to use convex mirrors. So why we are using convex mirror in dentist? Because they will capture it and it will get like okay, So if you ever went to a dentist, what they will use, they will give convex mirror at your beside the teeth, so that it will get enlarged and you will see the distinct clear images. And second, rear view mirror. So why, if you use rear view mirror, what has happened in the automobiles, at the starting or at the side mirrors, you can see those mirrors are nothing but convex mirrors. So why the convex mirrors means, it will try to capture the major area behind the car and it will try to keep it on the small area. Same way side mirrors also, with this side mirror you can see a larger area back side of your car. So this much area will be covered in the side mirror. Okay, and the parking mirrors also, if you notice in the park, like basement parking and all, you will see like a big mirror has been placed at the corner, so that it can capture from this side to this side. This much area will be captured and those images can be seen on the mirror. Okay, these are the uses of convex mirror. Next we have sign convention of reflection for spherical mirrors. Okay, so for this I will take an example of take anything. Let's take a concave mirror example. So sign convention means always first point. Okay, here I will write the points. In the next slide I will mention in detail. The first point, always object is placed at left of mirror. This is our assumption and we have to follow it. Second, distance is always measured from pole, either can be left side or right side. Okay, third, left is minus x, right is plus x, same way up is plus y, bottom or down is minus y. This is exactly which we use for our axis. Down is minus y and pole is considered as origin. Okay, so I will give an example, then it will be clear to understand. So if we take an example of concave mirror, so this is a concave mirror which is the shiny surface is inside, that is cover part is inside, and we have a pole here which is, then we have focus and we have center. So if you see here my previous parts, so distance of focus to pole is nothing but f, focal length. Distance from C to P is considered as r, which is radius of curvature. And suppose we have an object here, the object is AB. So this distance, the distance from P to the point A, for suppose, is called U. Okay, and this is denoted as negative. Why? Because it is left side of the pole. And suppose our image is getting created for concave, the image will be left side. It will created only left side except at the position between F and P. So first suppose the image is getting created somewhere. Okay, let's take it for this side. The image will be created at somewhere here. Okay, now we have the image here which is A dash B dash. So the image distance will be calculated as V, and this is also created left side, so again this is negative. If the image is getting created on the right side, then we have to consider it as positive. What about height? So this is considered plus h, whereas this is considered h dash, and this value is negative. Why it is negative? Because it is bottom, downward. So if you remember, like general axis, this is positive x-axis, negative x-axis, negative y, positive y. Same way here also. Okay, if it is placed right side of the mirror, you have to consider positive. Left side of the mirror, you have to put negative. Top of the, above the principal axis positive, below the principal axis negative. Okay, let's suppose, now let's try with the mirror formula is easy. The formula is 1 by u plus 1 by v is equal to 1 by f. Okay, u is object distance from pole. Object distance from pole. V is image distance from pole, and f is the focal length. of the mirror. So for convex, the focal length is considered positive. Why? Because it is right side of the mirror. Whereas for concave, it is considered negative. Why? Because the focal length of concave is left side, this side. Whereas for convex, it will be here. Okay. Then the last topic for today, which is magnification. Magnification is M, is denoted as H dash by H. Means image height by object height. Okay, I will write it here. H dash is image height and H is object height. Okay, and we have one more formula, which is minus V by U. We already know it is image distance from pole and U is object distance from pole, and this magnification formula is for mirror. Same as you will be having magnifications for lenses as well, that will covering in the next parts. Okay, in the next part, that is in part 3, we are going to cover refraction and convex and concave lens. So we are going to cover these topics in the next part. Okay, so I will also keep the links of part 1 and part 2 in the description. So if you want to have a check those links first and then come to this, then you will clearly understand. If you already have confidence of those two topics, then you can directly start with today's video, which is part 2, and part 3 will be coming mostly in next coming 3 to 4 days. Okay, so thanks for watching. So if you like this content, please like, and please do like, and if you have any doubts, you can comment. I will definitely check the comments and respond to you. And if you like this video, also please share to your friends. You might also need further revision for this chapter. So we'll meet in another part. Thank you so much.